joining us for today's ASCE Texas section webinar titled Trench and Excavation Safety. I want to apologize for the noise behind me. I'm at a TxDOT Environmental Affairs Conference. I guess these environmental folks are party animals, and I have no place to hide this. So I'd like to thank the branches for hosting viewing sites across Texas. The State Association for Civil Engineers. We are happy to provide this service, providing continuing education to the engineering community. If you are not a member of ASCE or the Texas section, I invite you to become a member so you can enjoy the benefits of this professional association. Please post your questions on the chat board, and I'll make sure they'll get addressed after the presentation. And now it's my pleasure, and I'm pleased to introduce and thank our presenter today. Today's continuing education training, Walt Catlett, PE, CSHO, the state engineer of the Texas Concrete Pipe Association. Take it away, Walt.
Hey, Mark, I appreciate it. Thanks for the opportunity to spend a moment with everybody on trench and excavation safety. As Mark said, I'm with the Texas Concrete Pipe Association, and I am a certified safety and health official with OSHA on the construction industry side of the house. So the items we're going to be talking about here come from OSHA, and I'm going to highlight a few things as we go along that point us to the federal document that this information comes from. You know, so often we are out on the job site or we're in a classroom and someone asks us, you know, at what depth do we need protective measures in place per OSHA? And we get all kinds of answers. And so we get a couple of different answers. And so what I want to do today is raise our awareness about that and make it so we're comfortable with that conversation. And so here's our learning outcomes I want to accomplish today. We're going to describe the differences between an excavation and a trench. And I would think most of us on this call would know that, but that's one of our outcomes. Describe the dangers of trenching and excavation operations. Identify steps to avoid hitting underground utility lines. Describe protective systems. Explain requirements for safety when installing and removing protective systems, and describe other excavation hazards. So those are our learning outcomes. We'll accomplish that. We'll do an introduction. We'll walk through pre-planning, talk about the different protective systems, and then we'll touch on additional hazards and protections. Real quick, the little picture you see on the slide, that's an OSHA pamphlet, and it's labeled Trenching and Excavation Safety. OSHA has a wealth of information on their website. If you haven't ever visited it, you should, because anything you want to know about safety is going to be there. And if it's not, you can ask them and they'll go find it and get it for you. But they have a ton of helpful tools. So Google OSHA and whatever the topic is, OSHA, protective systems, OSHA, depth of trench or whatever, and you'll see it. This manual is one of them. Just Google Trenching and Excavation Safety Pamphlet, and you'll get all the things that we're going to be talking about today. So right off the bat, in the chat room, I want you to go ahead and answer this question. There is a wrong answer and there is a right answer, but that's okay if you don't get it right, because that's what we're here to talk about, and to make sure we are comfortable on how we answer this. So at what depth are protective systems required by OSHA? 3 feet, 4 feet, 5 feet, or 6 feet? So take a moment and just go ahead and put a response in chat. And if you haven't ever done that, there at the bottom of the page, or at least on mine, you'll see an icon for chat. Click on it, and you can just type that in there and start placing your answers. And Mark, Mark and Mike, y'all let me know if I need to touch on anything there. At some point during the presentation, we'll get back to that. So, all right. So we had a couple people answer. It looks like and we have more than that in the room. So y'all step out there and be brave and go ahead and throw an answer for the heck of it. All right, our document of the document that OSHA has out there for us as it pertains to trench safety is 29 CFR 1926, and you see a picture of it up there on the right, and that is the regulation for the construction industry. So it's the construction industry regulation and standard, and where we go in this presentation to find excavation is in subpart P, not F like I have on my slide, but it's subpart P. P as in Papa. All right, and in that section, that subpart of 29 CFR 1926, because I know we all like, so I'm touching on this at the beginning, so you can go find one of these. It's broken down into 4 areas: 1926.650, 0.651, and 0.652. Then it has appendices A through F, and I just kind of lumped those together. Within 650, 1926.650, they address the scope, application, and definitions applicable to subpart P. So there'll be a handful of definitions: trench, competent person, hazards, just some basic things that apply to trenching. They even have a definition of a ramp. Now, if we were in a classroom and I were to ask you, the group, give me your own definition of a ramp, we'd get all kinds of different answers. And here's OSHA's answer. A ramp means an inclined walking and working surface that is used to gain access to one point from another. And you can see what it can be constructed of. Typically, when we think of a ramp, it might be earthen, might be made of earth materials. But anyway, here's their definition within 1926-650. All right. Within 1926-651, they're going to touch on specific excavation requirements. So sometimes when I ask the question, at what depth do we need to have protective measures? A lot of times people will say probably a 50-50 split. They'll say 4 foot, 4 feet, or they'll say 5 feet. And so I always say, well, you're kind of both right. But the reality is at 4 feet, OSHA tells us we have to have a means of egress from a trench operation. And here you see it before us, straight out of 29 CFR 1926 subpart P. A stairway, ladder, ramp, or other safe means of egress shall be located in trench excavations that are 4 feet or more in depth, so as to require no more than 25 feet of lateral travel for employees. So what OSHA is telling us right there is, if I have a trench and it's 4 feet or greater, I've got to have a means of getting in or getting out of that trench. It could be a ladder, or it could be a stairway. And that means of getting in and getting out of the trench can be no further than 25 feet from me. So if I got a 50-foot trench, or if I have a 60-foot trench, I'm gonna have to have a couple ladders in that trench to get in and get out of safely. And we've all been out on the job site, and we've seen trenches lengthy with probably only one means of getting in and getting out. OSHA tells us every 25 feet we need to have that ability. All right, that was 1926-651. There's a bunch of other things in there. Now I'm going over to 652, and these are the requirements for protective systems. So 651 covered the means of getting in and out of a trench, and that's at 4 feet and greater. OSHA tells us for protection of employees in excavations, each employee in an excavation shall be protected from cave-ins by an adequate protective system, except when the excavation is made entirely in stable rock or the excavations are less than 5 feet in depth. An examination of the ground by a competent person provides no indication of a potential cave-in. So there's our answer. At 5 feet or more, OSHA tells us we should have protective systems in place. 5 feet or more. Now, Keep in mind that OSHA standards are minimal standards. Those are the minimums. So a local agency can say, well, okay, OSHA says 5, but we want it to be 4 foot because of these reasons. So they can make the standard more conservative. They just can't make it less conservative. 5 feet or more. You'll try to remember that because you'll be asked again in the future. All right, then within Appendix B, you got appendices and A through F. I'm just throwing some things up there for us to look at. Within Appendix B, under the sloping and benching configurations, which are 2 protective measures, sloping being one and benching being another, you can see what they're telling us the configuration of our slope and or bench system should be. So sloping here, they're telling us in a type A soil has to be 3/4 to 1. Type B is 1 to 1 and type C is 1.5 to 1. And we'll go over those different soil classifications during the presentation. And so what that's telling us is for every 9 inches of horizontal distance, I got to have 12 inches of depth for type A. And for type C, for every 1.5 foot out horizontally, I can go down 1 foot or up, depending on how you're looking at that. All right. So those are our slope configurations. And then within that appendices, these notes are below it as well. And there's 2 key notes here. Well, there's 3, I guess I should say, but the one at the bottom is what I want to focus your attention on. Sloping or benching for excavations greater than 20 feet deep shall be designed by a registered professional engineer. 20 feet, greater than 20 feet, we have to have a PE design our sloping or benching for excavations. So that's worth noting as well. That's another dimension worth capturing. All right, within Appendix F, it shows us these different decision trees, at least that's what I call them. So you can see it there on the left. Following figures are a graphic summary of the requirements contained in subpart P for excavations 20 feet or less. Right. And it kind of walks us through. So here's figure 1. Is, bottom line, I'm out in the field and do I need protective systems? And this walks us right through it. Is the excavation more than 5 feet or depth? 5 feet in depth, yes or no? If the answer is no, then I go down here and check, is there potential for cave-in? If the answer remains no, then excavation may be made with vertical sides, less than 5 feet in depth. If the answer is they're going to have to slope, shore, or shield that trench. So I'll have to put some type of protective measure in place. If we select sloping, then we'll go to this figure 2, and it walks us through the different things for sloping. And it's all based on soil classification, whether it's a type A, a type B, or a type C soil. And then our other options are shoring and shielding, shielding being another term for what we'd be familiar with trench boxes. All right. So those are our 4 protective measures: sloping, benching, shoring, and shielding. All right. So that's 29 CFR 1926. Some of the items that are in subpart P. P is in Papa. All right. So what is a trench and what is an excavation? So a trench is defined as a narrow excavation made below the surface of the ground. In general, the depth of the trench is greater than its width, but the width of a trench is no greater than 15 feet. This is all laid out in OSHA's manual. And these, we all would say, well, Walt, anybody knows that. Well, OSHA feels it's important to define it. And so if OSHA feels it's important, I guess if we're in the world of installing pipe or out inspecting our job sites that we've designed, we probably should be familiar with that terminology as well. There's a handful of hazards that we are exposed to when we go out into the field and there's trenching or excavation. The biggest one here is cave-ins. Cave-ins certainly pose the greatest risk and are more likely than some other excavation-related incidents that result in worker fatalities. I'm sure a handful of you have heard this before, but 1 cubic yard of soil, 1 cubic foot, excuse me, 1 cubic yard. So if I'm in a trench and it's 4 foot in depth, I don't have to have protective measures. If a competent person said, "Yep, we're good on the 5 foot deal because it's 4 foot and the soil's stable enough," we're comfortable with that. And then I bend down to pick up a tool, and I got a 3 foot wall of dirt that falls on top of me. I'm in a serious situation because I have about 3,000 pounds, a bit more than 3,000 pounds on top of me. So that's pretty tough. We got to make sure our employers ensure workers enter trenches only after adequate protective measures are in place. This is a big one. I come from the concrete pipe world, and suspended loads are something I see on the job site every time I go to the field. And a 8 foot long by, 36-inch diameter pipe, if that chain or strap or cable, if it snaps and it falls and drops on top of this person, we're going to have a fatality on the job. So if you're out in the field and you see someone underneath a suspended load, point it out to them, and you may potentially save their life, or you may prevent them from a life-changing accident. All right, so what do the standards cover, and how do they protect workers? And we're going to walk through that. The whole reason we have OSHA is to protect the American workforce. That's what it's there for. It came about in 1972. Richard Nixon and the Congress at the time signed it into law. And so since 72, 50 years ago, we signed it into law, and we've had OSHA since then. And it was set up to protect the American workforce, right? And I don't really show it on here, but this is a good takeaway. OSHA has what's called the General Duty Clause, and the General Duty Clause is written within the standard, and it basically tells us that employers have the responsibility to make sure the workplace is safe for their employees. We call that the General Duty Clause, and there's two parts to it. There's the employer part of it, and then there's the employee part. The second part of the General Duty Clause is the employee, him or herself, is responsible for following all the rules and regulations that are in place to make the workplace safe. So the employer has a responsibility, as does the employee. All right, we're going to give this a shot and see if it works. Mark or Mike, y'all yell at me if you can't hear it. This is about a 9-minute video. We're going to watch it. It comes straight from OSHA's website. It's like I said at the beginning, they have a ton of information on there. If you Google YouTube OSHA soil classification, you'll get this presentation.
In the U.S., more than 800 construction workers die every year while on the job. One of the most dangerous types of construction work is trenching, which kills 40 construction workers every year. Workers can suffer death or serious injury within minutes of being caught in a trench cave-in. But these deaths can be prevented. The video you're about to see shows one of the steps, classifying soil, that employers must follow so that trenching work can be done safely. This video is not intended to be a complete educational tool. Instead, it is meant as an introduction for people who want to know more. Employers have a responsibility to provide a safe workplace and required protective equipment. You'll learn how having the right information about a construction site can help save lives. Each employee who enters a trench must be protected from cave-ins by a protective system if the excavation is 5 feet or greater in depth, unless it is dug into stable rock. A support system is not required if the trench is less than 5 feet in depth. An examination of the ground by a competent person provides no indication of a potential cave-in. 1 cubic yard of soil can weigh as much as a car, 3,000 pounds, and comes in many varieties. Some types of soil are stable and some are not. When digging a trench, it's important to know the type of soil you're working with so you know how to properly slope, bench, or shore the trench. This can help prevent a cave-in. OSHA requires that employers have a competent person to determine the soil type. A competent person is someone who can identify conditions that are hazardous to employees and who also has the authorization to correct these hazards. Or deeper must follow OSHA's rules. The appendices of the OSHA excavation standard show the various types of support systems that may be used, up to a maximum depth of 20 feet. Any excavation deeper than 20 feet must use a protective system approved by a professional engineer. For all excavations, a competent person must conduct a full investigation every day, or when any trench conditions change, to identify and remove any potential hazards. In this video, you'll see how a visual inspection of a construction site's soil is performed. You will also see how to test the soil using 3 of the most common methods: the plasticity test, the thumb penetration test, and the pocket penetrometer test. For best results, OSHA recommends that the competent person use more than one of these methods to test the soil. Knowing the type of soil makes it possible to determine the right protective system to keep workers safe when they're working in an excavation. Soil can either be cohesive or granular. Cohesive soil contains fine particles and enough clay so that the soil will stick to itself. The more cohesive the soil, the more clay it has, and the less likely a cave-in will happen. Granular soils are made of coarse particles, such as sand or gravel. This type of soil will not stick to itself. The less cohesive the soil, the greater the measures needed to prevent a cave-in. OSHA uses a measurement called unconfined compressive strength to classify each type of soil. This is the amount of pressure that will cause the soil to collapse. This value is usually reported in units of tons per square foot. Soils can be classified as Type A, Type B, or Type C. Type A soil is the most stable soil in which to excavate. Type C is the least stable soil. It's important to remember that a trench can be cut through more than one type of soil. Let's look at each type of soil. Type A soil is cohesive and has a high unconfined compressive strength, 1.5 tons per square foot or greater. Examples of Type A soil include clay, silty clay, sandy clay, and clay loam. Soil cannot be classified as Type A if it is fissured, if it has been previously disturbed, if it has water seeping through it, or if it is subject to vibration from sources such as heavy traffic or pile drivers. Type B soil is cohesive and has often been cracked or disturbed, with pieces that don't stick together, as well as Type A soil. Type B soil has medium unconfined compressive strength, between 0.5 and 1.5 tons per square foot. Examples of Type B soil include angular gravel, silt, silt loam, and soils that are fissured or near sources of vibration, but could otherwise be Type A. Type C soil is the least stable type of soil. Type C includes granular soils in which particles don't stick together, and cohesive soils with a low unconfined compressive strength, 0.5 tons per square foot or less. Examples of Type C soil include gravel and sand. Because it is not stable, soil with water seeping through it is also automatically classified as Type C soil, regardless of its other characteristics. Before testing the soil, it's useful to perform a visual test of the construction site. This will help determine if there are factors on site that will lower the strength of the soil. Here are some observations to make when performing a preliminary visual test of the soil around an excavation site. First, as the soil is being excavated, does it come out in clumps or is it granular? Clumps mean that the soil is cohesive. Are there sources of vibration near the excavation? Are there signs of previously disturbed soil, such as utility lines? Are there signs of water seeping through the soil? Is the soil fissured? Signs of fissuring include crack-like openings or chunks of soil that crumble off the side of a vertical excavation wall. If any of these conditions are met, the soil cannot be classified as type A. When performing a soil test, it's important to choose a good soil sample. Soil samples should be typical of the surrounding soil in the excavation, and additional samples should be taken as the excavation gets deeper. While the excavation wall is one place to take samples, OSHA recommends taking a large clump from the excavated pile, as long as the soil in the pile is fresh and hasn't been compacted. Test results can change as the soil dries out, so for the best results, samples should be taken and tested as soon as practical. Now let's look at the three main types of soil tests. The plasticity test, which is sometimes called the pencil test, is used to determine if the soil is cohesive. This test is performed by rolling a moist soil sample into a thread that's 1/8 of an inch thick and 2 inches long, resembling a short, slim pencil. If the sample can be held at one end without breaking, it is cohesive. Here's an example of what the results will look like if the soil is cohesive. Notice how the sample stays in one piece. Now look at what happens when the soil is not cohesive. The soil doesn't have the strength to hold itself together. Any soil that is not cohesive is automatically classified as type C, although some type C soils are cohesive. The thumb penetration test is used to quickly estimate the compressive strength of a cohesive soil sample. To perform the thumb penetration test, simply press the end of your thumb into a fresh clump of soil. If the soil sample is type A, your thumb will only make an indentation in the soil with great effort, as you can see demonstrated here. If the soil sample is type B, your thumb will sink into the soil up to the end of your thumbnail, just like this. If the soil sample is type C, your thumb will sink all the way into the soil clump, as you can see here. Your results for this test will probably be somewhere in between these results. For a more numeric measurement, the pocket penetrometer test can be used. A soil's compressive strength can be given a numeric value by using the pocket penetrometer test. There can be some variability in these results, so it's a good idea to run this test on a few soil samples from the same part of the excavation, just to make sure your results are consistent. A pocket penetrometer works much like a tire pressure gauge. A thin metal piston is pushed into a soil sample, and the penetrometer records the compressive strength of the soil. Be sure that the scale indicator is inserted into the penetrometer body until only the 0 mark is showing. To conduct the test, push the piston into the soil until it reaches the engraved line. Then simply take the reading from the scale indicator. It's important to recognize that a penetrometer may give false results if the soil contains rocks or pebbles, which won't compress. As you can see, type A soil will measure at least 1.5 tons per square foot. Be aware, however, that you can't classify a soil as type A if the excavation site didn't meet all the conditions of the visual test, if it is granular, near a source of vibration, or there are signs of previously disturbed soil, water seepage, or fissured soil. For type B soil, the reading will be between 0.5 and 1.5 tons per square foot. Type C soils are equal to or less than 0.5 tons per square foot. Let's review the main points from the video. OSHA classifies soils into three main groups.
All right, we're going to pause right there. And Mark, do you see, Mark or Mike, y'all see my slide?
Yep.
Okay,
Yeah.
I just want to make sure.
Yes, sir.
Okay, thank you. All right, so I'm just going to summarize the that video real, just summarize it. So here we have soil classifications, and from the video you saw type A, type B, type C. There's our sloping requirements, and we'll talk about that when we get to protective measures. And you can, and here's another way to look at those sloping requirements. You can see the type C soil is the least cohesive because it requires a flatter slope than the type A and especially the type B. So type A is 3/4 to 1, B 1 to 1, C 1.5 to 1. Thumb penetration test. You know, if we take a sample of the soil right after it's been excavated, we want to get a sample that represents the soil that has come out of the trench. So if you have different types of soil, you're going to have to go with the weaker of the samples, the weaker of the soil, right? And so, because that's going to give you the most conservative approach to safety. But if we have we take our soil sample, it's an unconfined compressive strength test. So we just clump that thing together with our 2 hands. We shove our thumb in it. If our thumb makes an indentation, then you've got a type A. If our thumb goes all the way to the depth of the thumbnail, you've got a type B. And if our thumb goes all the way into it, you've got a type C. You see there, this is a subjective test. And they say here it's the least accurate of the 3. This is one of our tests. The other one that we always do when we go out to the job site, you might say we don't even realize we're doing, is the visual test. We're watching that soil come out of the trench, and we can tell right off the bat if it's a cohesive or a non-cohesive soil, and the way it spills out of the bucket of the track hoe or the backhoe. So for our pocket penetrometer test for type A, you see that at the top, and as they said in the video, you need to get, your strength is going to be 1.5 tons per square foot. There's some of the examples of what type soil is typically type A. And what's real important is these items here that I just flipped up onto the slide. These are things that cause us to downgrade our type A. And if we're out there in the field, a lot of times we're going to we would be remiss if we didn't downgrade it. So here they are. The soil's fissured. It's subject to vibration from heavy traffic, pile driving, or similar activity. The soil has been previously disturbed. It's part of a sloped layered system, or the material is subject to other factors that require to be classified as a lesser than a type A. Type B is 0.5 to 1.5 tons per square foot. And there's some examples of the soils that fall in that category. And then items that cause it to go from a type B to a type C, just like a type A. You know, if it meets type B, but it's been disturbed, we're going to downgrade it to a type C. And then you see the other ones there as well. And then for our type C, it's going to be less than 0.5 tons per square foot. It's going to, a cohesive soil can be a type C, but generally we're looking at granular soils and then other items that cause us to classify soil as type C. Here's our pocket penetrometer. You can see there, it's a direct reading, spring operated instrument. You zero out the piston, and then you push that piston, the rod into your soil sample until you reach a mark on the pocket penetrometer, and that'll be called out on that tool. And you see here, pocket penetrometers have an error rate in the range of 20 to 40%. So none of this is really precise, but it does give us a feel for, am I in the range of a type A, a type B, or a type C soil? I think this is our last test, which is the plasticity test, or what they call the wet thread test or the pencil test. You take a sample soil, you roll it in your fingers, 1/8 of an inch approximately in diameter, about 2 inches long. Then you hold that vertically, and if it stays together, it's classified as cohesive. If it falls apart, it's a non-cohesive soil. Another key player out on the job site as it pertains to trenching and excavation soil is the competent person. And it's someone who's designated by the employer, who has the capability of identifying existing or predictable hazards, and who is authorized to take prompt corrective measures to eliminate them. a competent person. Depending on what, if we're doing scaffolding, that's going to be a different different requirements for a competent person. If we're in trenches, it's certain thing as well. And so here's some of those things that you got to be able to do as a competent person per OSHA. They've got to be able to classify soil. They've got to be able to inspect protective systems. They've got to be able to design structural ramps, have the ability to monitor water removal equipment, and they've got to have the ability to conduct a site inspection properly. So those were our ways for classifying soil. We were in the class together. I'd have us sit down and kind of go over it together as a group, kind of make y'all communicate that back to me. So consider yourself doing that right now. Have fun with it for a second. All right, pre-planning is so important. I do a lot of training with road crews at the county and the city level, and we do and contractors as well. And we talk about before we go to the field, what are you doing? Are you having a meeting to talk about what you're about to do? And that's so important to do that. And they generally say, yes, we do that. We're talking about what the task is that day, who's going to do what, and what hazards out there, and what equipment do we need. And I would just reiterate that to everyone on the call. Make sure you do some pre-planning before you go to the field, whether you're just going out there and inspect your job site, or you're actually out in the field every day and you're doing certain tasks. But pre-plan before, there's benefits to it. And you see some of those here at the bottom of the slide. If we don't, and we have to we have to stop or correct something in the field, it's going to slow down our operation. It's going to add cost to it, and it's going to make a cave-in or other excavation failure more likely. The bigger one to me is it's going to force us potentially to compromise or take an easier route than what we should be doing if we would have planned properly. And convenience is the beginning of an accident. And so I get out to the field, and I've driven 35 minutes, or who knows, depending on where we work, how long it could be. And I get to the field and I realize I don't have the right tool I need to do the job safely or efficiently. And so I use a different tool, or I actually do a task without some protective measure in place. So convenience is a horrible thing, and as it pertains to, I did it because it just inconvenience is really what I mean to say. It wasn't convenient for me to go back to the job site, go back to the workshop. And because of that, we had a trench collapse, or we used the tool that we shouldn't have been using, and something occurred. We all know we got to make sure we're doing excavations. We've got to contact our utility providers and let them help us know what's in the ground, get them to come out there and locate the utilities that are there before we start digging. And that's certainly something we always talk about as it pertains to excavations. So we certainly got to do it. And until we get them out there and those lines are marked, we're on pause. So once again, that's another planning thing. We're going to make sure we make the call in a time that allows us to not interrupt our schedule. All right, so we're going to talk a little bit about protective systems.
5 workers were putting a sewer pipe into the bottom of a trench with a ladder nearby to enter the trench. There was nothing in place to protect the workers inside the trench if the walls collapsed. While the workers were inside the trench, one side began to collapse. 2 workers were able to climb out using the ladder, but the other 3 workers were buried in the soil and unfortunately suffocated to death from the weight of the soil. Let's look at the events leading up to this tragic incident and see how it could have been prevented. Employers must follow OSHA rules to protect workers in trenches. However, here, the employer did not follow OSHA's rules, which led to these workers losing their lives. Let's go over the main points of OSHA's rules for trenches to see how to keep workers safe. All trenches must follow OSHA's rules. 1 cubic yard of soil can weigh as much as a car, nearly 3,000 pounds, So unless the trench is cut entirely into stable rock, protection against cave-ins must be used for all trenches more than 5 feet deep, or for any trench that shows signs of cave-in. Before workers can do any work in a trench, a competent person must conduct an inspection to identify and remove any potential hazards. A competent person is someone who can recognize hazards in the area and who has authority to take quick actions to eliminate the hazard, which may include temporarily stopping the work. Inspections must be performed at the start of every shift, after a rainstorm, or whenever conditions change. The competent person must also test the soil in a trench. OSHA requires at least one test by looking at the soil and at least one test by hand. If a person knows the soil types, they can pick the right protective system to keep workers safe when they're in trenches. OSHA classifies soil in a trench as stable rock, Type A, Type B, or Type C soil. Stable rock is the safest soil for a trench. Type A is the next most stable, and then Type B. And finally, Type C soil is the least stable. It's important to remember that trenches can have different types of soil based on depth and climate conditions. The competent person can choose from different protective systems for a trench based on the types of soil found. For all trenches deeper than 5 feet deep, or for any trench that shows signs of cave-in, OSHA requires sloping, benching, shoring, or shielding to protect workers from cave-ins. Let's review each of these systems and then see how each one could be applied to the cave-in incident shown earlier. We'll look at sloping first. Sloping protects workers by cutting back the sides of the trench so the sides slant away from the trench. OSHA's rules identify the degree of slope allowed for each of the different soil types. When trenches are less than 20 feet deep, these are the basic maximum allowable slopes for each soil type. Stable rock can be vertical walls, but cannot be undercut. For Type A soil, OSHA requires that the walls be sloped 9 inches out for every 1 foot of trench depth. For Type B soil, OSHA requires that the walls be sloped 1 foot out for every 1 foot of trench depth. For Type C soil, OSHA requires that the walls be sloped 18 inches out for every 1 foot of trench depth. It's important to note that this kind of sloping can only be used for trenches less than 20 feet deep. Any deeper, and the protection must be designed by a registered professional engineer. So now, let's look at the workers in the original scene who were stuck in the trench as it started to cave in. But this time, the soil has been classified as Type B. The trench has been properly sloped, and the spoil pile is moved away from the edges of the trench. The trench walls are not caving in, and the workers are safe while they work. Now let's review the shoring type of protective system for trench workers. Shoring uses various support systems to prevent soil and the trench walls from moving. There are different kinds of shoring systems, but timber and aluminum hydraulic are the two basic types. Aluminum hydraulic cylinders are the most common type of shoring, and they are typically installed using spot bracing, plywood, or stacked methods. To install the shoring correctly, you must first determine the soil type. The type of soil and depth and width of the trench determine the maximum vertical and horizontal spacing used with the members of the shoring system. If we use our example of a 3-foot wide, 10-foot deep, 40-foot long trench in Type B soil, the shoring system being installed would need to include 12 strong aluminum vertical shores, with 6 on each side of the trench. These shores, also called rails, will be connected by hydraulic cylinders every 8 feet along the length of the trench. A hand pump pressurizes the hydraulic cylinders until they fit tightly within the rails. Now that the shoring is in place, let's look again at the workers in the trench at the beginning of the video. As before, the workers are laying a sewer pipe into the bottom of a trench. But now the shoring system prevents the trench walls from caving in and keeps the workers safe. Sloping and shoring are ways to protect the sides of the trench so they don't cave in. Now let's talk about shielding, which is a way to protect the workers when they're inside the trench. Shielding involves using trench boxes, also known as trench shields, or other supports to protect workers inside a trench from collapsing soil if a cave-in occurs. The competent person should pick a trench box that is right for the soil type and all other site conditions. A trench box has 2 large plates, which are held apart by 4 horizontal cross members. These plates, or shields, must be between the sides of the trench and the work area. The shields are strong enough to protect workers inside from a soil collapse. The shields can be 2 feet above the bottom of the trench, as long as they can support the entire depth of the trench and there's no caving under or behind the shield. The top of the shield should extend at least 18 inches above the level of any materials that could cave into the trench. Trench boxes are typically used in open areas, but they can also be used with the sloping methods discussed earlier. So let's see how a trench box could have saved the workers that we saw at the beginning of the video. For our example, we'll assume that the workers are in a trench with type C soil and no sloping, but working inside a trench box. This time, as the workers lay the sewer pipe into the bottom of the trench, they are protected from any possible cave-ins. This example shows the importance of employers following OSHA's excavation standards to ensure that workers are provided with a safe workplace. These types of construction deaths are...
Okay. All right. That's another video that I like to incorporate into the training because it exposes us to another tool that OSHA provides, which is, like I said at the beginning and I've said throughout, they've got a lot of good tools out there, whether it's a placard, a flyer, a poster that you put up in your workplace, multilingual, it's super helpful. And that video right there is, you find it, YouTube, OSHA, protective measures, I think might be one, or you can go to that link I had at the bottom of the page. Here we'll just kind of summarize real quick some of those protective measures, and we'll wrap this up real quick, see if anybody has any questions. But they touched on in the video, shielding, shoring, sloping, and benching. In my line of work with pipe installation, what I see most of the time in the field are trench boxes, or it's a slope, or it's just a shallow trench and there's no protective measure required. But if they're using anything, it's either sloping or trench boxes. It's rare that I see shoring. However, I provide this training a lot to different skill sets or different professions. And so if I'm working with people who do a lot of water sewer work, which I'm sure a handful of people on this call today interact with, or y'all do that type of work and you've got contractors installing new water, new sewer on your job sites, they typically use shoring. That's typically what they tell me. So it's worth talking to the people you work with or contractors and say, hey, what does it typically do if you're interested, right? And so a big item on what protective system we're selecting, it's driven by soil classification, which is why we went over that at the beginning. The depth of the cut, is there water content in the soil? What's the weather? What's the climate? What job am I doing? Is a trench box more suitable in this situation than shoring? If I'm downtown in an urban area, is sloping even an option? Is benching even an option? So we got to keep all that in mind also. All right. And as we said before, 20-foot max. And if it's greater than 20 foot, then we have to get a registered engineer to design our protective measures. All right. And we've already talked, here's one of our items, sloping. Y'all have seen this before. There's, once again, you heard him say 9 inches horizontal to every 1 foot depth for sloping for type A, and then type B is 1-to-1, and type C is 18 inches horizontal for every 1 foot of depth. One rule that's in subpart P of 29 CFR 1926 construction industry standard is what they call simple sloping type A soil. So they do tell us, they do allow, if the soil is a type A soil and my trench is no is 12 foot or less, and my trench is going to be open no more than 24 hours or less, I can actually slope my trench at 1/2 to 1. So 6 inches horizontal to 1 foot of depth. Can't be any greater than, can't be 12 foot or greater, 12, cannot be any greater than 12 foot in depth. And my trench can't be open more than 24 hours. All right. So that's a kind of, that is in the standard. I just want to make you aware of it. The key takeaway on benching is benching can only be utilized for type A and type B soils. You see that at the bottom. If it's a type C soil, sloping or other protective measures must be used. All right, and there's a good look at our benching. And then, if we're not sloping or benching, we're going to be doing shoring, or we're going to be doing we're going to do trench box, right? And here's a look at those. Well, kind of. If we're using a trench box, remember it's got to be the trench box has got to be extended above the trench by 18 inches, right? And then, of course, soil type, strengths of the supporting system, water, weather, all those come into play. And then shoring, you heard them talk about hydraulic cylinders, timber or aluminum are the most common. And what I hear from the people who use this measure is it's more conducive. It's convenient. I hate to use the word convenient. It's easier to transport to the field, and it's more applicable to what they're doing for their job site than a trench box. Right, and then I think I'm going to stop right there. Let's stop right there and stop sharing. I'll just kind of talk to everyone just real quick. Some other things to consider when we come to trenches are other hazards that are in the trench. It's not just the trench wall sloping and falling up and collapsing on top of a worker. There are other hazards. We've got, especially in Texas, you've got some hazardous gases, some hazardous environments that you can create and can kill a worker or really damage their health. So we got to be conscious of that. Water certainly can be a hazard. When water gets in the bottom of that trench, it can erode the foundation for that trench wall, causing it more likely to collapse on you. So you got to keep that in mind. Vehicles in the area zipping by a trench could heavy equipment could end up in the trench. So we want to protect, barricade that area off from people down in the trench so they don't get impacted by it. Just some additional hazards we should keep in mind. And a big one is this: if you're going out into the field and you're inspecting a job site, one of the things that he kind of glossed over in the training is a spoils pile from whoever's excavating should be kept a minimum of 2 foot away from the trench wall, 2 foot. And so a lot of us will walk up to a trench and stand right at the edge of that trench with our toes hanging over the end, looking down, looking at what's going on. Well, depending on who you are, you might be 180, 250, 300 pound load that's bearing down on the column of soil that's on that trench wall. It could collapse. You could toss down into that trench and you could end up seriously injured, if not a fatality. Or you could call collapse on someone else in there. So if you're going in there in the field, know your hazards and don't make it more hazardous than it should be. All right, I'm gonna pause. Mark, do we have anything, any questions we got from?
Yes, we have a question come in. Can the slides be shared with the group? Walt, I believe you.
Yes, they certainly will be, and Mike will help us. Mike will help us get that out to the participants. Is that good?
I was monitoring the Q&A on that first question that came in about depth, and the answers range between 4 and 6 feet. So it reminds me of another fellow that went to UNT. He was a civil engineer, but in a business school, actually. But he told my daughter, and it sticks with her, that the answer to all questions is it depends. So it definitely depends. It's no consolation if you got a cohesive story that has fallen on top of you because it slipped over the speaker screen. Okay, have you checked cohesive soil?
Well, I couldn't agree more. It does depend, Mark. I mean, it really does depend. And, OSHA tells us 5 feet, and that's the minimum standards. But you get out to the field and you assess, a competent person assesses it, and you may decide, hey, we got 3 foot 9 inches. This stuff is sloppy. We need to protect our people. And so, yeah. So the question is, can you stack shoring? You can stack shoring system. You can certainly stack a trench box, and shoring systems can be used in conjunction with one another. You saw in the video where they had a trench box with a benching. So you could have a trench box with sloping. So the answer to that is yes.
But we have time for a couple more questions, maybe. Anything else? I had a quick question, Walt.
Yeah.
From my perspective, as somebody that isn't in the field as much anymore, a lot of the things that I hear about totally actually about accidents that happen to supervisors that aren't in the field as much for me. I shouldn't laugh about it because I'm afraid of fatalities. Somebody that goes out to a site and isn't accompanied by anybody and then disappears over the weekend and find them falling opposed to things walking. Do you hear of stuff like that?
Yeah. So you bring up something we've got to keep in mind. When we go out to that job site, even though say we're the project engineer, but we spend most of our time in the office at our desk doing all this type of stuff. When we go out to the field, it's dangerous, and we've got to be communicating with the contractors that are doing the work. Let them know that we're there on the job site. Make eye contact with anyone who's operating a piece of equipment. Wear protective, wear our PPE, make sure we're visible, that we have retro-reflective top or bottom, our hard hat. We have all the protective measures that the other workers are wearing. We're only out there for a minute in retrospect. And so just because of that, it's their job site. And you create a risk. So wear your hard hat, set the example, put your gear on, and protect yourself so you don't become a hazard. And then talk to people and let them know you're there. I said that before, but you don't want to fall in a trench and get buried, and then 2 days later someone comes looking for you because no one saw it happen. People need to know you're out there. So use good sense. The majority of our accidents or the majority of our fatalities and serious incidents fall into 4 categories. It's falls, just a simple fall. 50% of all falls, and that's where most serious injuries and fatalities occur. 50% of all falls occur at 6 foot and below. We might think it'd be a greater height, but it's 6 foot and below. And then you have others: being struck by a piece of equipment, being crushed by a piece of equipment, and then being electrocuted. Those are your 4 primary hazards. OSHA calls those the focus 4. So keep that in mind as well. Mark, great question. Great comment.
I think we are about out of time here. Walt, I just want to say how much we appreciate you coming in and talking to us about a very important subject. And remind everybody that